who will be taking us through the presentation. So Richard is our APAC sales director handling Asia and Pacific, which is Australia and New Zealand, and is responsible for the in this particular area. And within India, it's myself, Prasad Shetty, and my colleague Sushil Rajguru, who handle the India sales for Matcon range of products. And I think before we start this session, I would like to mention that we would be recording this session, and we'll be using this to display in our YouTube channel and the website video pages. So I hope it's okay with all of you guys. So if that's okay, then I think we probably can go ahead and start the session. So over to you, Richard.
Okay, thank you, Prasad. Before we do that, I'm just going to connect another device so I can share the content. So just bear with me. I'm going to start to share my screen. Okay, give that a couple of seconds to come up. Okay, so thank you first for joining. It's good to see so many people on board. Prasad said I'm the regional director for Asia Pacific. So I've spent just over 11 years working with Matcon now, from South America, Africa, India, China, all the way across to Australia and New Zealand. I spent 3 of those years working exclusively with the pharmaceutical team in India to support them with their work. So hopefully we can share a little bit about what we've learned and what we've done in that market since then. So we'll start and we'll look a little bit about who are Matcon, introduce ourselves. Some of you may be familiar with Matcon, some of you may not. We're more than just a manufacturer of IBCs. Yes, we make IBCs, but as well as that, we're making systems which suit our customers. So whether that's the way in which they're going to be implemented in the factory or how they're going to be dealt with, we're not just about delivering a quantity of equipment and leaving you to that. Matcon, with the powder handling experts, we want to support you through the steps and make sure that not just buying the equipment is the last time you deal with it. We want to be there side by side with you and make sure the system works. A little bit about us. Our head office is in the UK. We're a centre of excellence in the UK, and then we've got regional offices and regional test facilities in the US, China, Singapore, and India. Where we don't have our direct sales force, we have a network of agents supporting that as well. And we've got a dedicated after-sales support network. So in India, we have the ability to carry out maintenance, to carry out servicing, installation, carrying some spares, making repairs for you. And the project management, engineering, design, all of these are part of the service. We bring the engineering and design project management together in the UK, where we're able to collaborate and share best practice around the world. Matcon is just over 40 years, so 41 years ago Matcon was founded, making large valves to discharge powders from silos, moved on into IBCs to create systems, and the cone valve, which we'll look at later in terms of what it can offer, allows the full control of powders and eliminates segregation within the powder handling side of things. And in 2012, we were acquired by IDEX Corporation, where we joined Quadro and Fitzpatrick and Microfluidics under the Material Process Technologies umbrella. So we'll go back now and we'll just have a look at a little bit to begin with at the challenges that the industry faces within the market. We'll come back to this page a little bit later, but we'll focus initially on the challenges. Now, clearly, it's a competitive marketplace that we find ourselves in and that you as pharmaceutical producers find yourself in. We've got to get the highest productivity at the lowest cost, ultimately out of the factory, get the best return on invested capital and get the best productivity we can. Obviously, we've got issues around powder flow. There's no denying that. Segregation, ensuring the powder is flowing, it's not bridging in hoppers. And those last points, they really impact on the business's ability to be efficient and be productive and make the best money. If we think about things like the issues around segregation and powder flow, wherever you've got an operator having to make a manual intervention with that process, you've got the risk to the operator, you've got the creation of dust, you've got quality by inspection. You know, you've got to look at these things to make sure that you're maintaining the product, that you've got all of the powder out of the bin, you've got all of the material into the compression machine. Any powder that is left behind inside the process, inside the bin, inside of anything, is something that you can't then put into a compression machine and make tablets with. So the more we can get out of the bin, the more we can get product into the compression machine, into the capsule machine, ultimately the more units you can produce and the more money you can make. We're looking to help increasing efficiencies and reducing capex, because what we're able to achieve when we look at the way that the equipment is used later, a lot of the time is to actually produce more with fewer machines by getting a higher capacity through them, allowing customers to build up and start off stage by stage, investing in 1 or 2 lines and adding further compression machines as we move down, deferring the investment rather than having to build, you know, lines which are running at 50-60% capacity for quite a long time. We're able to gradually expand the process, gradually expand the amount of equipment that we're deploying in a factory to get the best out of the process. As I say, we'll come back to this page again in a few moments. But what we'll do to begin with, we'll just take a quick look and see, you know, what is the cone valve. We talk about the IBCs, but our IBCs, Matcon's IBCs, are different to any other bin in the market. We have this discharge device, a cone valve, which sits in the outlet of the IBC, and it's there to overcome all of the typical problems you get with powder flow, where other systems have failed. You know, I'm sure we're all familiar of opening a valve on a bin or seeing a valve on a bin opened and the powder just sitting there, or somebody having to get a hammer or shake it or vibrate it. These are all areas where, whilst we have some of those features, they're built into the process so that it's a simple automatic. The user, the operators don't have to get involved with that process to get the best out of the system. As I said, some of you may be familiar with this. On the left-hand side there, you'll see two parts. The IBC sitting at the top, it's movable. That's the bit that we can move around the factory. And then below that, the discharge station. That's fixed. That's either mounted on the floor, or it's mounted on a lift and place device, on a framework over a process equipment. Wherever we want to empty that bin is where we have the discharge station. The IBCs themselves, they come in a range of sizes, but ultimately they all fit with the same discharge station. So it's a very simple process. The operator simply loads the IBC onto the discharge station, either with a stacker truck, electric stacker truck, or with a pill lift, and that's it. The rest of the sequence is automated. So we'll have a look at the video now, and we'll show how the system comes together and how it works. I will pause the video as we go through that so I can point out some of some important details that we have there. So as we said, we have the two pieces there. The IBC is mounted above the discharge station, and we're looking to lower that down now onto that. The cone valve is in the outlet of the IBC and it's loose. And we spoke before about the ability to keep powder inside the process. What you would have just seen there is the IBC is loaded onto the discharge station. That lip seal was deflected out of the way by the outlet of the IBC. That means that we're creating a dust-tight, powder-tight seal between the powder on the inside of the process, on the inside of the discharge station, and the process environment on the outside. Again, making sure that we're not contaminating the product from the outside world into that, but also that any powder, any dust that we're generating is kept inside the process and finds its way actually into the compression machine or into the capsule filler. Because as we said before, if it's on the floor, you know, you can't sell it. If it's on a wall or in the air, you can't sell it. So as we move forward, we'll see now a cutaway of the cone valve. The discharge station rises and you'll see an inflation there. What has happened now is that the discharge station probe and the cone valve have become one piece now, so that when we actuate the discharge station, we'll lift the cone valve and allow powder to flow. So what we have now, valve is open and we've created an annular gap around which powder will flow out. So we spoke before about prevention of segregation and protecting the blend that we've got. Ultimately, what we want to do in this scenario is take a blend of granules and make sure they get to the compression machine, that they get to the capsule filling machine in the same state that they left the blender, whether that be a fixed mixer or an IBC blender, which we'll look at later on. The reason that we help to prevent the segregation is that the powder flows around the outside, around that annulus. There's no core flow. We know with butterfly valves and with other valve systems, we create a core flow. If powder was to flow down the middle of the IBC, we create rolling segregation, and that rolling segregation leads to the larger and the smaller particles becoming separate from one another. So we're controlling the powder, preventing that mass flow, but also we have the ability with a positive shutoff, the powder behind the valve, if we need to close the IBC, the valve closes with the powder. So what we can do in close coupled systems is have a refill to the compression machine hopper. And should there be any problems, should you have any challenges with maybe a bit of downtime on the system, because the valve closes with the powder, you can simply remove the bin, carry out any maintenance activities, and then bring that back to the process. So we'll carry on with that. And this valve, while it goes up, we can choose that we can have vibration on that cone. So for a difficult flowing granule, maybe where you've got some a lighter, fluffier products, we might need to have a little bit of a agitation within the mass of the powder to make it flow. But in other cases, we don't want that vibration in there, because if the powder is free flowing, vibrating it itself will create further segregation. So when we undock, it's a repeat of the docking process. The IBC is lifted away, and you'll see there that lip seal snaps back into place to make sure that there's no dust in the environment. The IBC is removed, and depending on how the process is carrying on, would either be replaced with another bin of the same batch of material, or it could be cleaned down, ready for the next batch. So that's how the discharge station works, how the cone valve works. We said, so we're preventing segregation, we're promoting flow, removing the operator from that process. Within the discharge station, we could add features like weighing, or like vibration. So feeding to the RMG, feeding to the granulator, you can confirm that you've got a completely empty IBC. So you're not producing a granule, having left some of the material behind in the bin, some of that powder material. Or, you know, again, making sure that we've got every last gram of powder, or last tens of grams of powder out of the bin, and we're compressing that into a product which can then be sold. So we go back to the slide that we were looking at earlier, and we'll just run us through a little bit more on the type of how we can help our customers address those challenges, that the needs that we've got. So we spoke about increasing efficiencies, preventing operators' involvement, quality by design versus quality by inspection. That's really what we want to do. So let's look at what we can do in terms of the equipment. So there's 3 points there, and they're quite interesting when we think about how we can work with this within the pharma market. The IBCs, they range in size from 200 liters to 3,500 liters. So we can match the batch sizes to the IBC size, so we can reduce the amount of product we're making. So we're not making to put on the shelf, we're not making to stock, or we're not reducing inventory, saving the customer money, saving you guys money, not tying up cash in inventory and work in progress. But also, it may be that as we see these the larger generic facilities with some high volume production and some low volume production, one batch size no longer suits the needs. You know, there will be some products that you could make, you know, 3,500, 4,000 liters every batch, 24/7, every day of the week. There are some you may only make 500, 600 liters at a time. So we can now match that. Removing risk, increasing automation, making it the operator's task to simply place the bin on the process, push a button to confirm they've done that, and everything else takes over. A handshake between the compression machine, the capsule filling machine, and the discharge station to make sure that neither starts before the other one's ready. So no risk of delivering powder to the process before you've turned the compression machine on. And again, any alarms, any errors between the two, we've got that conversation between them to make sure that we're overcoming that risk. I've seen a question just added in the chat there. We'll take those at the end if that's all right. Hopefully we've got some time. We've got another sort of 40 minutes, so we should get to those. So we've got these IBCs matched to the batch size. We've removed the operator's involvement. We've increased automation. And ultimately, we're moving materials around in a much more optimized way. One batch, one bin, collecting larger amounts of powders, increasing the volume, reducing the need for quality control. 3,500 litre IBC of powder needs the same inspection, quality control, quarantine as 1,000 litre IBC. So big bins, but those large IBCs that we're bringing into the process bring with it an inherent risk of the powder being compressed in the outlet. But again, we've got the cone valve, so we're very confident that we can lift that material, we can get the powder out of the IBC into the compression machine in a controlled and managed way. Whereas if you were to take a 3,500 litre IBC with a butterfly valve or slide valve, there's every chance that the powder would actually compact in the bottom of the bin, leading to the need to have manual intervention. And again, whether that's taking the lid off, going in with a rod, or just simply hitting the side of it, you're damaging the process equipment. You're introducing a risk for the product to go out of specification. In terms of our experience, we've been doing this for more than 30 years. It's actually more than 40 years now. I suspect this part of the presentation was done around the 39th anniversary of Matcon, so it wasn't quite 40 years. We're operating globally. Our business is structured in such a way that we have regional business lines. As I said, I've been looking after the Asia Pacific one. We have one in EMEA and one in Americas. Each of those geographical regions has different needs, has different focuses. So by operating in a global yet regional basis and having our localized teams, we're able to support our customers better. In India, for example, we have service offering operations, we have repair, we have fabrication, we're making bins, we're making discharge stations, we're fabricating blenders there. So actually everything that we need to supply to the Indian market, probably 95% of it can come from a local factory in Baroda. So no need to bring that in from overseas. And we experience of working with branded and generic manufacturers around the world. Our history in pharmaceuticals started in API, really, but has moved more into the OSD business in the last few years. And we are starting to see a shift from what used to be very sort of short production runs with lots of cleaning between batches to the pharmaceutical companies now wanting to almost operate a bit like a food company where downtime is killing the business. If you're not making tablets, if you're not making capsules, you're not generating money. So the sooner that we can turn a process around, the faster we can get a compression machine running, the better. And that's the sort of the experience that we've taken from the last few years. In terms of what we do, we'll do everything from working from a greenfield factory where there's no facility to build up, to looking at existing facilities, working with our design teams to make sure that we're overcoming the needs and the challenges that you guys all have. It could be something from a simple line up to multiple lines. And the beauty of the process, if you've got a particularly challenging production suite, you don't have to invest in an entire facility. We can go unit by unit, product by product, and start to invest and adapt, overcome the problems that you're seeing bit by bit. So what we have there, we're showing just the kind of the areas that the unit operations that the Matcon system can work with, from dispensing, granulation, blending, feeding to compression and cleaning. Obviously, that's our idealized factory. But let's take a look at what you guys probably recognize as a typical sort of production facility. In this case, single floor, small drums being used to move powders around, vacuum transfer between processes. It has its advantages, don't get me wrong. There's nothing wrong with producing a factory to do this. It's relatively low cost of building. The capital equipment cost is low, and it's safe, it's familiar. It's been used like this. People have been making drugs like this for years. There's no risk around that. But what you have along this is open transfers where you've got dust potentially coming into the atmosphere. There's an operator risk, there's a GMP risk. It takes forever to clean. You've got to clean that entire process down. It's a crowded production area. You've got lots of drums being moved around. You've got the challenges of tracing those drums. How many came out of the batch? Where have they gone? What are we doing with them? So if we look at how we can integrate a bin system to that, and we take a single floor, we're using gravity now rather than using a conveying system to get the powder from one step to the other. The same stage is still taking place. We're dispensing, we're granulating, we're blending and feeding to compression. But all of these transfer points are now closed. There's no dust in the atmosphere. We've got a safer environment for our operators. We've got a safer environment from a GMP point of view. More powder is staying inside the IBC, and ultimately more powder means more tablets, which means more revenue for the business at the end of the year. It's a relatively low cost building, no floors, single floor. We're using gravity to transfer the material, and gravity has always been free, and I would imagine even the best will in the world, no government will ever tax gravity, so we should be okay to continue using that. It increases productivity. We're able to move more powder in a single go. So where on the previous slide we saw a number of drums waiting by the compression, and you've got a lot of on and off from the compression machine to load and unload of drums or tip drums. In this case, we're taking one batch from the blender to the compression machine. What we would typically do at this stage is probably collect a number of lots from the fluid bed dryer, and then blend those to homogenize them and then feed those to compression, rather than that single unit transfer when we're looking at the drums on the previous slide. Of course, there's a disadvantage to that. I'm not going to suggest this is the best way of dealing with it. It's a single batch. Because you've got everything in the same space, you can't run different materials within that space. You've got to clean down between them. And the production now is relatively busy. There's a lot going on. You've got IBCs being moved around and other bits. But it's a very common design that we've supplied a number of units to India in this way, using pill lifts to make those transfers and those elevations. An alternative way of doing that is to split the process. So what we've actually got here is that the IBCs move on a separate floor to the process equipment. So the operators at the tablet press are kept away from the movement of IBCs. We've got a cleaner, more open area, still using gravity, still got the closed transfer of the material. It's a less crowded area, so safer from an operator point of view. That upper floor, the material handling floor, it allows us to put maybe our IBC washing, other bits and pieces up there, so we can keep all of that dedicated, and we just have on the ground floor small rooms where we can contain a tablet press, where we've got the ability to keep from a GMP point of view, keep the product safe, keep the operators safe, and protect the batch. Obviously, again, there will be a disadvantage to this. There's a higher capital cost. You're now building 2 floors. You've got to move things up across those floors, whether that's with elevators or material lifts and those kind of things. The operators can't see what's going on. So on the ground floor, the operator at the compression machine doesn't know what's going on at all. He can't physically see it. So there's a requirement for the additional automation. But that's why working with a company who is used to fulfilling contracts in this way, we have the ability to maintain that and have that automation by mimicking, by having a replica between the 2 floors. So whether the operator's upstairs or downstairs, it's clear to see what's happening between those 2 areas. So they're the ways of carrying out that. What we'll do now, we'll just go back and we'll look at a couple of more processes. So we've looked at how the cone valve works. We've kind of looked at what the process looks like and what it can look like. So there are 2 parts to the process now where I want to look at in more detail. So it's obviously, we'll take a quick look at the blender. So obviously that's where we're going to bring the multiple lots from the from the fluid bed dryer, bring them together, make a homogeneous mix, and then we're going to feed to compression. So we'll look at that later. So we'll just have a quick look at the blending side of things. So the blending system, see, this is a photograph in our test plant. We're looking to eliminate the downtime. So whereas in a lot of scenarios, a blender may be in the same room, you'd use a pillar-mounted blender, then you'd maybe have batch splitting after that. We would advocate not doing that. We would advocate having a blender in a dedicated room. The reason being, with the Matcon container blender, there is no contamination, no risk of contamination between batches. We're removing cleaning between batches. So what we want to look to do is have a single blender mounted in a single space where we bring IBCs in, and they could be multiple products into that space, and then they go off into the next step where they're then compressed or put into capsules. By doing that, we have one blender feeding multiple compression machines, whereas having even a pillar-mounted blender in each of the production suites adds cost, adds maintenance. You've got a degree of qualification of training that the operators are required, where in this case we can have a dedicated personnel who operate blending, and then the others who don't. That blender you see there, that's a 1500 litre IBC, but the blender that we offer is able to blend IBCs from 200 litres to 3,500 litres. So we're talking a batch size of somewhere between anywhere up to 1,500, 2,000 kilos of powder going through that process, down to 100 litres or so. Typically, the blender itself, we can operate anywhere between 80% and around 30% fill volumes. In most cases, our pharmaceutical customers choose not to do that. They generally have a set fill volume, and whether it's a 200 litre IBC at 80% or a 3,000 litre IBC at 80%, that's how they operate. Our food customers, on the other hand, are slightly more, let's not say brave, but they will operate in a slightly different way. They will go from 25-30% fill volume to 85 and 90% fill volume, but they haven't got to validate the process. They haven't got the FDA looking over their shoulders to make sure they're doing things right. So the idea, one blender feeding multi-compression machines with multiple batches. We'll show you the blender in operation, and I'll just take a drink of coffee. So the video that we're looking at here shows an industrial type application. So we have a safety cage around the blender. Typically in our OSD facilities, that will be a dedicated room, but the technology is similar. So in order to access the blender, there's a key. That key, once the door is unlocked, remains in the door. That key is needed in order to energize the control system. So whilst ever the door is open, whilst ever the key is in the door, the blender can't be operated. So we're loading the blender onto the IBC onto the blender, sorry. We'll lower it down, and that piece of the cylinder you saw at the bottom holds onto the cone valve. So the cone valve is loose within the IBC, and when we invert it, we don't want it to fall out. Then a hydraulic system closes the cage, and we simply rotate the IBC around the center of rotation. So the door is closed, and that key now is released for the operator to use in the control panel. There's a number of interlocks on that system, one to make sure the bin is there, one to make sure the lid is there, one to make sure that the cone is in place. So again, we're making sure that no mistakes can happen. No need to check. The automation system will do that for us. The IBC itself is rotated 20 degrees against the blender itself. So whilst we're creating end over end blending, we're also creating a degree of side to side motion within that. And also the cone valve in the outlets of the IBC almost bifurcates the powder every time the powder slides down the IBC, so increasing the amount of shear that we're generating within that. Contour blenders, container blenders rely on that shear in order to create that. So we had an added feature with the cone valve and that offset angle to make sure that we have the correct blend. And then once we've finished, we take that out. The blender is now inactive. We've isolated that. The control panel is isolated, and we can remove the IBC. Again, we're showing a forklift truck removing that. See, I don't think I've ever seen a pharmaceutical plant in the world where we're using such a device to move things around. It clearly wouldn't be hygienic for you guys, but this just shows that it's an illustration of what we're doing. So literally, the moment that IBC is taken out, we can go with the next batch. Now that IBC there, 1,500 litres. The next bin into the process could be a 500 litre IBC, it could be a 3,000 litre IBC. We're introducing a greater deal of flexibility into the process with that single blender feeding to multiple production lines. That's the compression lines. So that's the blender. We said we then look at the feeding to compression. So we'll go back through to that part there. And what we have is feeding to the tablet press. So this is obviously the most important part of the process, because this is where we take what is a homogeneous mix of powder. But the point that what we're doing now is we're adding value to this process. Until it's in the tablet, until it's in the capsule, it's not a saleable product. So what we're doing here is we're using the discharge station, we're using the cone valve to protect the mix, removing segregation. There's no core flow. We've got mass flow in the IBC. So the product comes down together, no funnel effect, no rolling segregation from that. With a consistent flow of powder, we can lift up to 2,000 kilos of material with that cone valve. So we're able to consistently open and discharge powder, even on the larger batches where we've had that potential compression of material in the outlet. No need to hammer and bang the bins or take rods in there and do that. It's a fully automatic operation. You put the IBC on, a little sensor confirms an IBC is in place. There's a handshake electronically to the compression machine, and the process starts. In actual fact, in most cases, the compression machine, the capsule filling machine, is controlling the process. It's taking over for us. We just tell the system we're ready, and when the compression machine is up to speed and ready, it will give us a signal. We will open the valve, depending how the system's set. We will then deliver powder into the hopper of the compression machine. If there's a level probe in there, if it's close coupled, when that level probe hits the high level, we'll close our valve and the compression machine will discharge the powder. And then either based on a timer or a low level sensor, we'll refill that hopper. But again, because we've got the ability to get the powder out, we know that when we call for powder, we will replace it. So we can run the machines faster, the compression machines faster, because there's no risk associated with what if there's no flow. With a traditional system, if you open the bin and powder doesn't flow, you need to make sure you've got sufficient buffer in the compression machine so that you'd have to stop the line. With a Matcon system, you don't have that same concern. So you can run the machine faster because you don't need to have that buffer. So we have customers in India who are operating side by side, a machine with Matcon, a machine without Matcon, identical powder, identical compression machines, and they're able to get between 10 and 15% more material through the process than otherwise. So on a large scale, if you've got 6, 7, 8 compression lines within a facility, that's actually close to the cost of one compression machine being saved by using the Matcon system, getting 10 to 15% extra production out of each one of your lines. You save the capital investment of a whole compression machine, plus the maintenance, plus the cleaning, plus the downtime associated with that. We've mentioned before the powders inside the process. We've got containment. There's no dust, and we've got more productivity. No unscheduled stops. We can keep the process going. So that's just a very quick look at the benefits that we're bringing to compression. But again, the point to note is we're not reliant on operators. Everything's automated. Quality by design. No need to check inside an IBC to see if it's empty. No GMP risk for powder being on the floor, being on the walls, being in the operators. From a health and safety point of view, yes, there's a need for operators to wear PPE, and they should wear the PPE, but it's still, and they would have to wear PPE even with the Matcon system, but it would make it a much nicer place to be, a healthier place to be, a more comfortable place to work if the place isn't full of powder, full of dust. So there's two sides. There's what you need to do and what makes the environment a better place to work. So now we've taken the powder, we've dispensed it, we've blended it. It's now compressed. You see at the bottom there of that picture, those two white square blocks. They're tablet IBC. So what we look at now is what we do with the tablets once they're compressed, because we can also improve the efficiencies around the tablet handling side of things. So let's go and have a look at what we're doing with that. So you'll find the part I need here. So what we're seeing there is the tablet IBCs, those white boxes. across all of those process areas: coating, packing, inspection, cleaning. So we're collecting the IBCs from, collecting the tablets from the compression machine, from the capsule filling machine, in these plastic IBCs. Plastic, so they don't make a mark on any uncoated tablets. It's softer. We put a spiral inside them so that they can, we're not dropping the tablets from the outlet, we're gently lowering them down into the process. So what we can look at is where we're deploying these in various parts of the system. So obviously that's the tablet IBC, 500 liters up to 1500 liters in volume. Again, they're moved around the facility with a walk behind truck. And we can see there the spiral that we spoke about in the inlet to slow down the flow of powder tablets, into the system. Collecting from compression, we've got a 5 liter powder IBC on top of that Fete machine there. It comes out of the compression machine, elevated through the deduster, through the metal check, and then we have a further elevator there to deliver it into the IBC. Obviously, double-sided machines, we'd have an IBC at either side. Now, compare that to traditionally moving tablets through a facility with drums. 25 kilo drums. If we've got 250 kilos of tablets coming off that line, you've got 10 of those drums. So if we can replace that with a 250 kilo batch IBC of tablets, we're saving the process that we'd normally go through tenfold. So for every label you would write, every bag you would write, every note you would write to identify that batch, rather than doing it 10 times with a drum and bags, you either don't do it at all with an IBC system because we're relying on maybe barcodes or other electronic tags, or you have to do it on one occasion. So we're reducing the risk of error, we're improving batch traceability, and actually making the place a bit neater, a bit smarter place to work. So that's collecting from compression. Then we can go feeding to coating. So in this case, we're showing a image there. This is using an elevator, a pill lift to lift the IBC up. We have a mobile chute, which is designed to distribute the tablets into the coating pan. So again, what we're doing, we're moving an entire coating batch within reason in a single IBC, and we're filling it far quicker, far more efficient. So actually, rather than that process again of 10 drums, opening the bags, removing the seals, removing the liners, lifting the drum, tipping it 10 times, we can do that in a single process with a 250 kilo IBC of tablets. And again, when we're feeding to the packing machine, taking that batch of tablets and just in one go, loading with a pill lift and leaving it there to go through. No need to have an operator standing on steps, tipping drums, or having a tablet elevator. All of those parts of the system add to complexity, add to operator involvement, and the risk of mistakes being made. So again, quality by design, make the automation work for us, have the handshake so we don't have an operator starting to feed tablets before the packing machine's ready, or tipping tablets before the coater's ready. It's all done with automation for us. So just finally, what we'll do, we'll have a look at a video showing a system in process. What I'll do, I was going to skip through to the last minute of the video where we're focusing on the tablets handling, because we've seen the discharge station operation, we've seen the cone valve in operation, we've shown the blender. So what we'll do, we'll just skip through about a minute and a half in the video. This is actually a factory, a client of ours in China who put a Matcon system in, single floor facility. So let's just run on through to about 130. So what we'll now see is the tablet IBCs being deployed within the factory. So you might recognize that's the video of the photo we looked at before. And if we've got larger coaters on site, obviously there's no reason why we can't collect multiple lots within IBCs and then deliver those to a coater where we can then coat a larger batch. And again, because we've got that, that larger volume, a larger buffer of tablets or capsules available to us to use, you can start to run those machines faster and get those efficiencies. There's less risk around, is that hopper of the blister packing machine going to run out of tablets, so we need to slow it down because it takes 3 minutes for a guy to climb a ladder and refill that hopper. We can start to expand the capability and the capacities of the process equipment, improving the efficiencies, getting more tablets, getting more capsule through the factory. So in about 39 minutes, I suppose, I think we've gone through that. I did see we've got some questions. So what I'll do, I've got nothing more for us to share here. So I'll stop sharing the screen from my iPad, and then we'll take some questions.
Yeah. So Rich, you want to go the questions one by one? So I think participants, of course, you can put those questions in the chat box, as we already have some questions. And also you have option of, unmute your mic and then ask the questions as in you feel comfortable. So I think the first question that's there, Rich, is that from Sumit. What to do to avoid crushing of MUPS during compression?
So are we talking MUPS or MUFs?
He has written MUFs, but I believe that is MUPS.
Okay, so the powder, the machine itself, the discharge station and the process is relatively. I guess we're talking about the mixture of the powder and the MUPS within that. So it's a relatively gentle discharge. So in terms of the material itself will flow freely at that point. So it will be no different to dealing with any other form of bin system. So if we're comparing, like for like, on a polyvoid is a relatively free-flowing product like a MUP system, it would be exactly the same way of working as it would be with a cone valve, with a butterfly valve or slide valve. There would be no difference, apart from there's less risk of segregation of that product where we've got that different particle size, perhaps.
Sumit, does it answer that? Are you happy with the answer? Okay. Yeah. Okay. Yeah.
Okay,
yes,
so we'll go to the next question, which was this cone. Oh, sorry, Sumit.
Yeah, during compression, can we have to close the discharge valve for the MUP specifically?
So if you're closing the discharge station during production, the design of the material as a valve closes, obviously it doesn't slam close. There's a point at which it does close down. So as the valve is closing, the powder will fall away. There is a soft seal around the cone valve. So within reason, if there were to be some material there, it's not a knife edge seal. It shouldn't be a crush seal. But it's like anything. How friable are those MUPs? It's a question of depending if it's a very soft. If it was an agglomerated sort of product, then there may be some damage. But if it's a small micro tab or something like that that's been compressed or being coated in some way, I would expect they would be strong enough to take that. But obviously, it's not a yes, it's not a no. It depends very much on the individual nature of that particle.
Okay, thanks.
I think the next question is from Ravikant Shelke. So the question is, does the cone valve technology suitable for potent product handling?
So we are using cone valve technology in potent product facilities. Obviously, during the actual transfer of material between the discharge station and the process, it's completely dust tight. So from a exposure point of view, there is no exposure, operator exposure at that point. But again, it depends on the level of potency. And I think we do have applications in OB3, OB4. We do have IBC systems running in Bangladesh in hormonal facilities. But again, it's in some cases we have maybe items being used at higher operator at OEM levels, but maybe PPE is being used to allow that. But I guess it's a question of balancing between the need of that cone valve technology versus the potency of the material. If you've got a relatively benign product that isn't going to segregate, that it flows well, then probably, but the absolute requirement is that there's OEB 5 or higher, then maybe cone valve technology isn't the right one. But if you've got the powder simply doesn't flow from a butterfly valve IBC or simply doesn't flow from some other form, then there's always a conversation to be had about how can we implement that. We have solutions that we can put in place. So, for example, we can put local extraction ports, we can put air washing within the discharge station. So there are things that we can do to the system to allow us to increase the potency of the material that you can use, but there's always going to be a trade-off.
Okay, thank you. Understood.
And then the third question, does the blender have an inching facility? So we're talking about being able to move the blender incrementally around. Is that the question you're asking? The picture?
Yes, correct.
Okay, it does. But typically, you shouldn't need to use that. Obviously, the rotation speed and time is set in the control panel. And at the end of the process, the blender returns itself to upright. The only time that you may need to use the inching facility would be in case of a failure, if we've lost power to the system. So the system resets, but it requires a manual intervention to return it to upright and then restart the blending process. So only in extreme circumstances would there be a need to use the inching facility, but yes, it does have that. What, in terms of the request app, what reason would you need to have that inching facility? What's your thought behind that?
The same reason what you told, power failure in case of.
Yeah. Yes, it's
That's
very.
good. Thanks.
Yes, it's very important that obviously following any failure, whether that be a power supply, typically we can supply a UPS with sufficient capacity to protect the PLC, protect the IPC, but obviously with the best will in the world, a UPS for a 11 kilowatt motor is going to be very complex. So we protect the batch data, the recipe data, allow the blender to fail, but obviously we need to have a control over that. So yeah, the operator needs to inch that back to upright before starting again.
Right, Richard.